Today we are going to make the falling donut block from Super Mario. We can think of our falling donut in 4 different parts. First, it's a platform. Second, if the player stands on it for too long, then it's going to third, shake, and then fourth, fall. And then for a bonus fifth, we're going to respawn it so that after a certain delay, the player can interact with it again. I'm using the Unreal Engine 5.6 third-person template, and I'm going to right-click to create a new blueprint class of type actor because all I care about is that this ends up in the world, and I'm going to call this my donut. I'm going to open this up, and now we're going to build out all of the components that we need first. In the top left-hand corner, we're going to add first a static mesh, and this is going to be what the player can stand on, and I'm going to call it the mesh. And then next we're going to add a collider. This is going to be a box collision, or what I'm going to call our collider. And then next we're going to need something that's actually going to do the moving. And to do that, we are going to use the interp to movement component. And I'm going to call this mover. With all of that set up, we can now make our flesh suit. So if we click on mesh, we can go into the properties and we're going to set the static mesh to be a cube. I'm choosing this cube. Now, all we're going to do with the collider is make sure that it pokes out a bit on top because that's going to be what we're concerned about the player being on. To do that, I'm going to lock my scale first and I'm just going to scroll it up until I can see it. And that comes in at about 1.6. So I'm going to dial that back to say be 1.4. And then I'm going to unlock the scale and I'm going to drag the Z axis until I poke out a bit. And then I'm just going to make sure that I don't phase through on the bottom, and we'll do something like this. That's all we really need to do for the looks, so now we're going to go and do the actual coding. So let's go into our event graph, and I'm going to get rid of both tick and OnActorBeginOverlap. But we are going to use begin play. Let me give you some context on what this mover component does. Basically, what this can do is it can move on a list of points. And it's going to go from point to point until it reaches the end, and then it's going to leverage different behavior to either ping pong or reverse. Inside of the mover, if I click on the component, a whole bunch of things are going to appear. The big ones for us are going to be the duration, which sets how long the entire sequence takes to run, and then this control points. Control points is the list of stops this object is going to make as it journeys around. Then the other big one here is behavior type. In this case, we're going to be leveraging the one shot because we want to go down through our path and then stop. But these other options might serve you in different circumstances. So the thing we need to do first is we need to set up our control points so that this mover component knows where to go. And the way that we're going to do that is we're going to drag off of mover in our graph and we're going to get our control points and then we're going to add into this array. Now, what are we going to add? We can see this here is a type of control point structure. And in order to add something to this, I'm going to drag off and I'm going to look for the word make, which allows us to make a control point. Now, what I like about these control points is it has this Boolean here, position is relative. If this is enabled, we can change the perspective away from world and the world view. So if I look at this object here, our position in the world is this location here. So what this means is if this is true, and we set the position control point to be all zeros, we are going to take the point in space that this object exists, depending on where we place it in the world. And that is definitely where we want our first control point to be. The next thing we're going to do is we're going to add another control point. And this one is going to be where we end up after the movement is done. And to do that, I'm just going to copy paste and make another control point. And we're going to want to move down, which is the Z axis. And to move down in the Z axis, it's going to be a negative number. And let's just do negative 100. Again, you can play with this depending on what specifically you want to have going on. Next, I'm going to get another reference to our mover to keep things clean. And the next thing that we need to do is we're going to pull off and look for the word finalize. Basically, once you have set up the actual control points array, you need to finalize it for it to recognize that this is the path that it should take. And then the last thing we're going to do is we're going to drag off mover and we're going to look for restart movement. And our initial direction here is going to be 0 because to start things off, we do not want our mover to move. And the reason that this behavior is going to work is inside of our mover's properties. If we look for activated, we can see this auto activate is true. And I find that it's way more consistent if we're restarting the movement with certain values rather than trying to activate and deactivate, because that causes certain events to fire when I don't want them to. And anyway, this slice of code here is going to set up our movement so that after a certain trigger is met, we're going to be able to move from where we start in the world to 100 points lower than that. Now we're going to create that trigger. And the trigger that we're going to use here is we're going to go into our collider, and we're going to scroll all the way to the bottom where all of the events are, and we're going to do OnComponentBeginOverlap. And then what we're going to do here is we're going to make sure that the other actor that we're overlapping with is A, and we're going to click the soft reference here, and we're going to make sure that this is the type of class that we want to be able to activate this. For the purposes of this tutorial, I'm just going to say that any character is able to activate this behavior. In the event that a character is the one overlapping, so off of true, we're going to set a timer by event. And I'm going to do by event instead of by function because I find that it reads better for a tutorial, but they can both do the same thing. Now, next what we're going to do is we're going to right click on time and we're going to promote this to a variable that we're going to call time before fall. And I'm going to compile so that I can set the initial value to be 2. And then after, in this return value, we're also going to promote this to a variable that I'm going to call our time before fall handle. And this is going to represent the timer as it is counting down. Now, once this timer completes, we're going to fire an event. So we're going to drag off of event here, and we're going to look for custom so that we can add a custom event that I'm going to call fall triggered. So when the fall is triggered, the donut needs to jiggle. The jiggle is what's going to tell the player that things are about to get bad. And the best way that I've found to do this little bit of a jiggle is we're going to use a timeline. So let's right click, search for timeline, scroll all the way to the bottom for some reason and hit add timeline. I'm going to call this our falling jiggle. And I'm going to connect the play from start to this event because I want this falling jiggle to play the same way every single time it's triggered. Now, what are we going to want to have jiggle here? And that's going to be our mesh or our little flesh suit that exists in the world. So with our mesh, we are going to add a local offset. And the way we're going to do that is we're going to adjust our location based off of the value that we're going to set up in our timeline in a second. So I'm going to drag off of our delta location and I'm going to search for something called lerp, and we're going to lerp by vector. So what the lerp does is we're going to have an alpha. I'm going to keep this as 0, 0, 0 because that's going to reflect our origin. And I'm going to change the X to 10 so that we just have a little bit of a difference here. Now, what is our alpha going to be? Our alpha is going to be the jiggle that comes out of the graph. So what we're going to do here is we're going to double click on our timeline and we're going to hit this plus track here. And let's add in a float track. I'm going to call this our jiggle. And now we're going to set up the actual timeline that we want to have happen. The first thing that we need to do is we need to adjust the length. The length is how long this timeline is going to play for. I'm going to say that this should be about half a second long, so I'm going to change this to 0.5. Next, we need to add some points that are actually going to be covered in our graph. So what we're going to do is I'm going to right click and add a key, and I'm going to do that 5 times. Now what we're going to do is we're going to go one key at a time and we're going to set them up. I'm going to have each key be 0.1 seconds apart. So our first key is going to be at timeline 0 and it's going to be at value 0. Next, I'm going to do the last one, which is going to be at 0.5 and is also going to be at value 0 because we want to have our position in the world be the same at the start and the end so that the object isn't actually moving and is easy for us to predictably respawn. Next, we have these 3 things in the middle. So I'm going to say at timeline 0.1, we are going to have value 1. Then at this second position here at time 0.2, we're going to be at -1. And then at this one here, we're going to change this to be 0.3. And then this is also going to be at 1. And then it's going to settle back into 0. And then in order to make sure you can actually see the curve that you've generated, you can hit this or this, but I'm going to hit this to zoom to fill it horizontally. And then I'm going to press the other one to fill it vertically. And now we can see all of our points in the actual scale. And we can see that as we go, we're going to jiggle back and forth. I'm going to go back to my event graph and I'm going to grab the jiggle float that we just created and I'm going to drag that into the alpha. And I'm going to make sure that every time this updates, we're going to add that local offset. And then when we're finished, we're going to need to want to fall. But just to make sure that you can see what we've done so far, I'm going to quickly compile save. I'm going to go into my level. I'm going to drag my donut and I'm going to place it right over here. And I'm going to make this pretty large because I don't want to have to miss. So we've got our giant donut. That's actually a little too big. I'm going to drag this back to be a little bit thinner here. There we go. That should actually be manageable. And then what I'm going to do here is I'm going to play. I'm going to go and jump on my block. And we can see after that time starts, we jiggle back and forth, which will then start the fall. Now, what you probably noticed here is as we jiggle, we can see that we are not moving back to the same spot that we started at. And the reason for that is actually I made a little bit of an error with our timeline. So if we go back into our timeline with this last point, we actually want our value to be -1 as we finish, because that means as our timeline finishes, we are going to have a -1 alpha, which means we are going to be leveraging with A, which means we'll be at 0, 0, 0. So if I compile that and go and hit play again, when I jump on here, we'll jiggle, and then we end up right back where we started. So now with the jiggle complete, the next thing we need to do is actually fall. So once we are finished with the timeline, I'll drag that over to here, we are going to need to do the actual falling. We're gonna get our mover, and we're going to restart the mover's movement. And this time our initial direction is going to be 1. So once this is finished, we're going to restart our movement so that it actually moves by giving it this value of 1. So now if I compile this and go and play again, let's see where we're at. We jump on the donut, we shake, and then we fall down. So next we need to make sure that this disappears when we hit the bottom or stop moving. The way we're going to do that is we're going to add another event. If we click on our mover and scroll all the way down to where all the events are, we're going to look at onInterp to stop, which is called when interp2 has come to a stop. Since we're using that one shot, it's going to stop once it ends. So let's click the little plus here to get that event inside of our graph. So what's going to happen when we stop? Well, we want the mesh to disappear, and we want the mesh to no longer cause collision. So the way that we're going to do that is I'm going to drag off of mesh, and we are going to call get visibility. And we're going to search for set visibility, and we're going to set our new visibility to be off. And then we're going to drag off of mesh again, and we're going to set collision. And we're going to take set collision enabled, and we're going to say no collision. So once the movement of our actual donut is stopping, we are going to remove the mesh from both collision and visibility so that the player falls to the ground. Let's see that in action. So we jump on our donut, we jiggle, then we fall, and we fall to the ground. Now the next thing we're going to want to do is we're going to want to respawn the donut after a certain time has passed. And the way we're going to do that is very similar to how we set up the jiggle. So off of the set collision enabled here, we're going to drag and we're going to set a timer by event because I think that's better for visibility. We're going to manually set the time, but you're welcome to just make this a variable. And I'm going to say after 2 seconds again. We're never going to be pausing this for this tutorial, but again, if you wanted to ever pause or stop this timer, then you'd want to promote this to a variable. But what's going to happen here is we're going to create another custom event that I am going to call respawn. And then when we're respawning, what are we going to do? We're going to basically do the inverse of this. So what's going to happen? We're going to set our visibility to be true, and we're going to set our collision to be collision enabled for query and physics. And then after that, we want to make sure that we don't immediately start falling again. So we're going to take our mover and we're going to restart the movement with a 0 so that it no longer is moving. And then the last thing we want to do is we want to put our block back at its starting position. And the way that we're going to do that is we're going to capture our starting position, and then we're going to set our location to go back there. So let's scroll back up to our begin play method. And right before we do anything with the mover, so I'm going to drag this back, I'm going to right click, get actor location, and I'm going to right click on the return value to promote it to a variable that I'm going to call it my init location. So when the game starts, we're going to capture where our block starts. And then let's scroll back down. And then when we're respawning our block, I'm just going to move this to the side. We're going to set our actor location, and let's connect these dots. And we're going to set it to be that initial location that we just captured in begin play. So let's see what this looks like. Let's compile, let's hit play. I jump on donut. It jiggles, we fall, we dramatically lose, and then it respawns. Perfect. Now, one thing I think is important to show off here is if I go back up our ramp and then jump on our donut again, it's going to go and repeat itself. So it's going to jiggle, fall, and the same thing happens. We get that full behavior. Now, the last thing to do is we need to make it so that if our player is jumping or not actively standing on our donut, then it's not going to trigger that fall. So the way that we're going to do that is we're going to click on our collider. We're going to go down to our events again, and we're going to look for OnComponentEndOverlap. And then all we're going to do here is we're going to grab our timer handle that we had set up before, and we're going to see, is this timer active? So is timer active by handle? I'm going to hit B and click to summon a branch. And then I'm going to say, if our time before we fall is currently active, then we are going to clear that timer. So the way we clear a timer is we're going to hit pause, timer, by handle. We can throw in the handle that we have here. And then by pausing the handle, we have successfully stopped it from occurring. And to answer a question that I see come up all the time, yes, when we hit start timer, we are going to start this over. We would have to specifically trigger unpause in order to restart the timer from where it currently is in execution. But every single time you hit start timer, it's going to refresh or restart that timer. So let's try this here. I'm going to hit compile. I'm going to hit play. I'm gonna go over here, I'm gonna jump, and I'm gonna keep on jumping. And you can see here that our jiggle is not triggering. And then when I stop here, the jiggle triggers and the behavior flows. And that is a very basic donut block that you can use to make your platformers a little more Mario-like. It'll respawn, it'll do the whole thing, and if you got value out of this tutorial, subscribe to the channel for more videos just like this one.